All right, now that we know all of our circle basics from 10.6 and 10.7, we're going to get into a bunch of different theorems with circles. And that first one is going to be about tangent lines. So first we need to define some things. A point of tangency is where a line or line segment intersects a circle in exactly 1 point, or at exactly 1 point. So this line right here would be a tangent line, because it intersects the circle at just this one spot. It kind of like grazes the top of this circle. All right? Then, if a line is tangent to a circle, so this is what we know from tangent lines, then it is perpendicular to the radius drawn to the point of tangency. So basically you have this tangent line right here. So here's our tangent line. Yeah, that is the same tangent that we know from SOHCAHTOA, but in this case this is called a tangent line. All right, now this is a radius because it goes from the center to the outside of the circle, and tangent lines meet radii at a 90-degree angle. So they are perpendicular. So you might have a problem just like this. ED is tangent. Oh, we should have the letters in this. So hang on. Should be ED is tangent to circle F at point E. So it's tangent at point E. That's where it intersects circle F. All right. So then we're going to find the length of X. Well, if it is tangent, then I know that's a right angle. So then I have a right triangle right here. And I should use Pythagorean theorem. So 3 squared plus 4 squared equals x squared, because across from our right angle, remember, has to be our C, and then the other ones could be A and B or B and A. Doesn't matter. All right. So here we have 25 equals x squared. Don't forget to square root. The answer is not 25. X is actually 5. All right. Now let's look at our next theorem. So if a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent. So basically, these two theorems right here are just converses of each other. All that happened was that the order changed. Remember, converse is like the shoes, you switch your laces, so we're just switching the order of the statements. So up at the top it said, if the line's tangent, then it's perpendicular to a radius. This says if a line's perpendicular to a radius, then it's tangent. Okay, so for instance here, determine whether MN is tangent. So now we are going to see if MN meets LM at a right angle. So we will test this also with our Pythagorean theorem. Well, I know this leg here is 3, so 3 squared plus 4 squared equals, and now I'm testing to see if this is a right triangle, so I need to know all of this right here. Well, you actually do know it. This part here is 2, and then right here, this section that you're missing is actually a radius because it goes from the center to the outside. Well, this right here was also a radius, so you know this is 3, which makes this whole side 5. So now I have 5 squared, 3 squared plus 4 squared is 25. 5 squared is also 25. So it checks out, and MN is tangent. Oops, tangent. Okay, oops, let's go blue. There we go. All right, so determine whether PQ is tangent to R, so same kind of problem again. This is a radius, so I know this is 4, so this whole thing is 8. I'm checking to see if my right angle is right here, okay? That's what I'm not sure about. So my legs are 4 and 5, and my hypotenuse is 8. So 4 squared plus 5 squared is 41, but 8 squared is 64, so that is not equal. So not tangent. all right? Make sure that you know where the right angle would be in this picture so that you know you are using your hypotenuse and legs correctly. Let's go on to the back. All right, now we have what we like to call the snow cone effect or the snow cone problems. So if two segments from the same exterior point are tangent to a circle, then they are congruent. Okay, so this is the exterior point that we are talking about in this theorem. So it's outside of the circle. And then these are both, these lines, I'll highlight them in blue. These are both tangent lines. They meet just at one spot right here and right here. They're just going to graze the edge of those circles. So if those are tangent, then we know that these two should be the same length. This is why we call it a snow cone, because if you were to flip that over, it kind of looks like a snow cone. We got this picture right here. So here's the tangent lines we'd be talking about, and those would be the same length. So if we have a problem like example 3 right here, I've got a couple snow cones. So I know that here's one cone, so those are congruent. Here's another cone, so those are congruent, and I'm going to mark them all with one line because they're all going to end up being the same because they're both congruent to this one. All right? Anyways, if all of those cones are the same length, then you are just going to solve for x. So negative 2x plus 37 equals 6x plus 5 since they are equal. I'm going to add this 2x because I don't want to deal with negatives. 37 equals 8x plus 5. Subtract 5. 32 equals 8x. Last step is to divide by 8, and we get that x is 4. And let's check. It just says to find x, so we are done. All right? So you're always just looking for those snow cones. We got one last example. Example 4, triangle ADC. So we are looking at triangle ADC right here. Is circumscribed about circle O. That means that all those lines that make up that triangle are tangent to the circle. So find the perimeter of triangle ADC if EC equals DE plus AF. All right, a lot of information. Let's break this down and I know I've got some snow cones, so let's see what information I've got. So I'm going to label all the congruencies in my snow cone. So here's one snow cone. Those cones are equal. These cones are also equal. These cones are also equal. So let's fill in what I do know. If I was given that this one was 6, I know that length is 6. I was given this one is 19, so I know this is 19. Okay. Now I don't know these other lengths. I don't know both of these, this bigger cone over here. So this is where I might use this piece of information right here. Let's see. EC is equal to DE plus AF. Well, EC is what I'm trying to find. That's this length right here. And I know DE right here is 6 plus AF right there. I filled in was 19. Okay, so EC then becomes 25. And if I know EC is 25, I know CB right here is also 25. Now you can just add around. So you can do 25 plus 6 plus 6 plus 19 plus 19 plus 25. Or you can add up each side. So 25 and 6, this side makes 31. 6 and 19, this side makes 25. And 25 and 19, this side makes 44. So I'm just going to add 31 plus 25 plus 44. And that equals 100. Perimeter, remember, we just are measuring the length or adding up the lengths of the sides. So that was all we had to do there. We just had a few snow cones to use. All right, so that's all we've got. We got tangent lines, our perpendicular, and we got the snow cone effect. And that is it for 12.1. Bring these notes filled into class.